systems of equations, I need to explain to you three types of systems. All a system means, and you've seen these all before, all a system means is that you're going to have more than one. So when we're dealing with systems of equations, we're going to have more than one equation that we're going to deal with. First of all, we can have independent systems. Independent systems simply mean that you're going to have one solution. So when you're talking systems of equations, you could have independent systems, and that's going to result in one solution. If I give you a set of equations, we need to figure out what makes them independent. So the first equation I'm going to give you is y equals negative 6x plus 8. And I could graph that, right? Where would I start? At 8, and then my slope would go down 6 and over 1. So I could take and I could graph a line that went through 8 and then went down 6 and over 1. Right? And that would be that line. So when you're sketching, you don't have to be exact, but let's get you a line on there that closely resembles that one. And then if I gave you another equation, 3x plus y equals negative 4. Could I graph that line? Not yet, but if I change a little bit on it, then I could graph it pretty efficiently, right? So if I change it to a y equals, where my y is isolated, then I would know my slope and I'd know my y-intercept. So let's go ahead and fix that. So if I'm looking at this second equation, what do I need to get alone? What do I need to isolate? The y. What do I need to get rid of then? The 3x. Are you with me? So subtract 3x from both sides. So you have y is equal to negative 3x minus 4. Now that I have it in slope-intercept form, what's my slope? Negative 3. My y-intercept is negative 4. So I could, in theory, go ahead and graph another line that went through negative 4 and had a slope of negative 3. Thank you. Went through negative. So stressful, so stressful. And we're going to pretend like these will keep going, right? And we'll pretend like those are perfectly graphed lines for these two equations, even though obviously they are not. But I can see that if they kept going, that these lines would in fact intersect at some point further down the graph. Would you agree? So an independent system of equations will have two equations minimum, and it will intersect in one spot, and that intersection point down here is its solution. So an independent system of equations has one solution. One solution for my graph. And they could be a mixture of graphs. They could be absolute value graphs and a line. They could be a quadratic graph and an absolute value graph. I mean, there's many different options, but the way that, for the sake of graphing, a couple of lines is pretty easy. So I can see that there's one solution, and they will also have different slopes. Did these have different slopes? Yes. The first one had a slope of negative 6, and the second one had a slope of negative 3. So independent graphs or independent systems will have one solution. Those one solutions will have the two lines will have different slopes. All right. Dependent. A system that is dependent will have infinite solutions. If something is infinite, what does that mean to you? Forever, everything. Infinite is everything, yes? So if I have infinite solutions, then let's write down a couple of equations. Let's say I give you a line that is negative 6x plus 4y equals 2. Infinite solutions. Okay, so negative 6x plus 4y equals 2. And my other line will be 3x minus 2y equals negative 1. Now, could I graph these? Yes. I would have to put them in y-intercept. So let's see, is there another option to see maybe what's going on with these lines? Let me tell you what it looks like first. I would have a line graphed somewhere. We're going to pretend like that's my line for one of these equations. And then I would graph the next line from that equation, and it'll do this. It'll graph one right on top of the other. If your lines, when you graph them, graph one right on top of the other, then every solution for one line is a solution for the other line. So you have infinite solutions for both. So if I know that that's going to happen, what can you say about those two lines? They will be the same equations. And I mean the same slope, the same y-intercept, everything will be the same. So if the lines graph one on top of the other and they give you infinite solutions, you're looking at two identical equations. Now, sometimes they're disguised. And if you look at what I've given you for an example over here, do these look like the same equation? So this is a negative 6 and this is a positive 3. They don't look alike yet, but you're already seeing that they have something in common. The 6 and the 3 have what in common? A negative 2. And the 4 and the 2 have a negative 2 in common. And the 2 and the 1 have a negative 2 in common. So the easiest thing to do, since I'm seeing that they all have a common factor, is I would take this second equation, because it's the smaller one, and I would multiply everything in there by negative 2. So I would take negative 2 times 3x is negative 6x. And negative 2 times negative 2y is positive 4y. And negative 2 times negative 1 is positive 2. And now, can I say that my equations are exactly the same? Yes. Absolutely. So these will graph one right on top of the other. They have infinite solutions. So if you know the solution for one, you know the solution for the other. Questions so far? So independent, one solution. Dependent, infinite, and you've got one other kind, and it's called inconsistent. If something is inconsistent, what does that mean to you? Are there things in your life right now that are inconsistent? Yeah. For example, sleep. Sleep for high school students is definitely inconsistent. What else is inconsistent in your life? How about your finances? Are your finances inconsistent? Absolutely, because they're never the same. They're never the same. Your sleep cycle is never the same, and your finances are never the same. It's inconsistent. So if things are inconsistent, that means they're not going to be the same. That means there's not going to be a solution. If it's inconsistent, there is no solution. And the reason there's no solution would be because the lines are going to be parallel. So those are the only types of lines that will never intersect, and they're not going to overlap. Parallel lines are very distinct. They have to be two lines the same distance apart for infinity. So inconsistent graphs, no solution. That is because they are parallel lines. Now, in Algebra 1, this is when parallel lines were introduced. Parallel lines have very specific indicators within their equation. So if I give you an equation, y is equal to negative 3x plus 9, and y is equal to negative 3x minus 7. And I tell you that these are equations for an inconsistent system. Then what can you tell me about them? What is the same? The slopes. Parallel lines will have the same slope every time. In Algebra 1, you were taught about parallel lines and perpendicular lines. And parallel lines will have the same slope. That means when I look at a graph, I'm going to see a line that goes, I don't know, up 2 over 2. And I'm going to see another line that's equal distance apart that goes up 2 over 2. So my slopes will be the same. I do realize that the slope, negative 3, does not match the line that I have on my graph, and that's okay. Be flexible. Because I have positive slopes on my graphs and negative slopes in my equations, but you can do it. Parallel lines are inconsistent. There's no solution because it doesn't matter how far out you go, they'll never cross. So independent, dependent, inconsistent. Questions? One solution, 1,357,000 solutions plus one, and no solution. Right, okie dokie. So we're going to solve systems by graphing. And so you have a little handout, and I've given you some steps that we can go through, and that's fine. We're going to rearrange the equation if necessary. We're going to graph it. We're going to graph until we can see that it intersects or doesn't intersect. We're going to notate where that solution is. So looking at the first one, it says y minus 4x is equal to 2. Can I graph that? Yes, but I need to put it in y equals. So I need to get rid of the 4x. I see that y is subtracting 4x, so how do I make it move? Add 4x. And let's go ahead and add it to the other side to keep it balanced. So y is actually equal to 4x plus 2. Make sure you're always writing those equations in the right form, where it's mx plus b. And if I went ahead and graphed this, where would I start? At 2. I always start at the y-intercept. So go up your y-axis to 2, put a dot. That's where I start. And then my slope is positive 4. That means I go from my y-intercept, I go up 4. 1, 2, 3, 4 over 1. And I do that until I run out of graph. And then I probably need to go backwards. And then I can go ahead and draw a line through my point so I have a nice linear graph. And then I'm going to look at the next problem. On the next equation, is it in the right form? No. I know I have a 3y is equal to 6x minus 18. I need to divide everything by 3. So please don't leave any terms out. They'll get their feelings hurt. Divide everything by 3. So what I'm left with is y equals 2x minus 6. So I divided every term by 3. Questions? And then I graph. This one tells me to start at the y-intercept, negative 6. So go down to negative 6 and use my slope. My slope is 2. That means I go up 2 over 1. And it looks like it's not crossing, is it? it's moving further away. So let's go back to our y-intercept at -6 and go backwards, please. So go down 2 and over 1. And it looks like at some point off the graph down here, ooh, that's a terrible line, but some point off the graph down there, there's going to be an intersection point. I can tell that's going to happen. And if your teacher could draw better, you would see that your solution is going to be down here somewhere. In theory, on a normal graph, you would be able to see what that location is. So this has how many solutions? 1. So this is independent. This is independent. Independent, that means it has 1 solution. And we're going to go to the next problem. Here we go. The next set of problems say y minus 1 is less than or equal to 2x. So I'm dealing with an inequality, and that's fine. Is it in the right form? No. I need to move my 1. So to move that 1, I've got to add 1 to both sides. So it should be y is less than or equal to 2x plus 1. If it's less than or equal to, is that broken or solid? Solid line. And it's less than, so I'm going to be shading below. Good. So let's go ahead and graph our line. We start at 1, and our slope is 2. So go up 2 over 1 until you run out of graph. And then go backwards. We want to make sure we've got plenty of points to choose from. Ooh, that's a good line for a smartboard drawer. I'll give you a minute to graph. As we look at the second equation, again, is it in the right form? No. So I need to do some movement. I'm going to leave my -5y here, and I'm going to move my 2x. So I'm going to subtract 2x from both sides. So that leaves me with a -5y is greater than -2x plus 10. I'm going to keep that in the mx plus b order every time, even if it's negative. Then divide everything by a -5. Do you remember what happens when you divide by a negative? Yeah, that symbol's going to flip. So I'm going to have y is less than 2/5 x. That's a slope. I want to keep it in a fraction form so I know my rise and my run. And I've got negative divided by negative, so it's positive. Then minus 2. Start at -2, and let's slope up 2 over 5. And I forgot something, so don't draw your line yet. Get your dots, but don't draw your line. Because I forgot to tell you something. Going back to this first equation, I knew I had a solid line, but I forgot to shade. Okay, so I need to shade, it's less than, so shade below. And when you're talking about a line, it's sometimes confusing. But if you think about this line, is to the right or to the left below? To the right is below. So I'm going to take the highlighters that are on my table, and below this line, I'm going to shade, and don't color it in because that gets a wee bit more confusing. So go ahead and color or shade that in for that first line. And then you can go ahead and draw the line for the second one, but be very careful because the second equation has a less than symbol. So will you have a broken or a solid line? Broken. So don't let that get you. You got to go ahead and draw your line, but you got to draw it broken. And then when I draw that broken line, switch highlighters with someone because I have to shade less than again, correct? So now you need to make sure you shade below the broken line. So the easiest way to do that is to trade highlighters, and then I'm going to find my broken line, and I'm going to shade below my broken line. And when I shade below that broken line, do I have a place where my two colors cross? Yes. That's a solution set for the system. But these two lines, they actually cross in one specific location. Can you find it? I go -2, -3. And if I look, those two lines that I graphed, they specifically cross right there. This has one solution, so it's independent. It has many solutions, but it has one solution. And where the lines cross is at -2, -3. Okay, dropping down, let's look. I've got 3 times the absolute value of x minus 1 plus 1. And then I've got y equals negative absolute value of x plus 3 plus 5. Ooh, absolute value. Yay. Let's graph the first one. Is it in the right form? Yes. Do you know your vertex? Yes. Vertex is agent K, right? What's your H? 1. It's -1 in here. When I pull it out, it becomes +1. K is 1. So my vertex is at 1, 1. And what's my slope?
3.
Good. And that's A, right? A is equal to 3. So I'm going to go from my vertex up 3 over 1. Up 3 over 1. That only gives me half of my graph, though, remember? So to get the other side of your absolute value, go back to your vertex and go up 3 and left 1. And then go ahead and draw your graph. They're equal signs, so I don't have to worry about whether or not it's broken or solid. Ooh, that was terrible, but we can work with it. And then we need to find the vertex for the second line and the slope. Vertex for the second line is where? -3, 5. And what's the slope? -1. Because is there a number in front of the absolute value bars? No. So I need to replace it with a 1. Since my slope is -1, what do I know is going to happen with this graph? It's going to be oriented down. So I start at my vertex -3, 5. And from there, I go down 1 over 1. Down 1 over 1. Is it crossing? Yes, it is. But go ahead and do the other side of your absolute value, please. Down 1, left 1. There's an equal sign, so I don't have to worry about dotted or solid or broken. They're just solid lines. And I can see that my graph crosses where? Because yours is going to be far more accurate than mine. Where does my graph cross? At 1, 1 for sure. So it has one solution at 1, 1. Okay, so we're on the last page. We've got 2 more questions left. If I look at my equations, am I in the right form? It says x minus y is greater than 3. Not in the right form. Okay, so what do I need to do? Get rid of the x. I do that by subtracting. So if I subtract an x from both sides, let's write down what I have left. I have negative y is greater than negative x plus 3. Questions? Can I have negative y? No. So how do I get rid of the negative? By divided by negative 1. And if I divide this by negative 1, I've got to divide everything over here by negative 1. So I'm really just changing all the signs. But what happens when I divide by a negative? The symbol flips. So I actually am going to have y is less than x minus 3. Can I graph that line? Absolutely. Where do I start? Right, I'm going to start at negative 3. And I'm going to go up 1 and over 1 because my slope is 1. And I can do that forever and ever until I run out of space or energy. And then go ahead and connect those, but be careful because what kind of line do I need? If I go back and look, it says y is less than. That is a broken line. So your line will be broken going through this graph. And I'm also going to have to do some shading. Where am I shading? Shading below because it's less than. So you're taking care of all of that. Broken line, shading down, and getting ready for the next line. The next line says x plus 2y is less than 6. Is that in the right form? No. I got to manipulate it. So what am I going to get rid of? Get rid of the x. Move it to the other side by subtraction. So you have 2y is less than negative x plus 6. So far, so good? Now, what do I do? Divide by 2. Get that y alone, but please divide every single term. And did I divide by a negative? Nope, so leave your symbol alone. You've got y is less than, what is in front of this x that I can't see? A 1. So this is actually a negative 1 over 2 x. There's my slope. Plus 3. Solid or broken line? Broken. Let's graph it. Where do I start? Start at positive 3. And then my slope says to go down 1 over 2 because it's negative. So from 3, I go down 1 over 2. Down 1 over 2. Oh, am I crossing? Perfect. If I cross that quick, I can be done. As long as I've got at least 3 points graphed. Broken line. Shading. Does it have any? It says less than, so I better shade below my line. Shading below my line is going to be here. So I clearly see on my graph, I see some that's just blue, some that's just green, and then I see a mixture. When my lines cross, do they cross in more than one spot? No. They cross in one intersection point right here. So what's its solution? It's at 1, 2, 3, 4, 1. Is that accurate? 4, 1 is my solution. And we have one problem left. We need to make sure we change our equations to where they're in the right form. So if I look at negative 4x plus y equals negative 4, I need to get rid of the negative 4x. So add 4x to both sides. Y is equal to 4x No, minus 4. Can I graph that? Let's go ahead and switch the other one so we can graph all at once. So subtract your 2x from both sides, please. So y is equal to negative 2x plus 8. And let's graph. I want you to graph and then we'll check it. So here's the first line. This is your 4x minus 4 line. I'm going to go ahead and graph the next one where I start at positive 8. And then I go down 2 over 1, down 2 over 1. And I can see clearly I'm going to have an intersection point. My solution will be at 2, 4. Make sure you glue this in.